This video introduces the Modbus communication settings and instructions for Delta robots. Delta robots primarily utilize the Modbus protocol for communication. Modbus is a master/slave architecture protocol. It is used for signal exchange between Delta robot controllers and peripheral devices, including vision systems, PLC control systems, and robot-to-robot communication. Modbus registers are used to store and transmit numerical data for Delta robot controllers. The Modbus address ranges are 0x1000 0x1FFF for volatile memory, and 0x3000 0x3FFF for non-volatile, retentive, memory. For detailed information, please refer to Chapter 12 of the RL Manual. Next, we will introduce how to read and write Modbus registers using the Delta robot controller. First, open the DRA Studio software, go to the project page, and create a new project. Select the newly created project to edit, then navigate to the RL programming page. Enter your pre-edited code into the RL editor. Use the write Modbus command to perform the write function. Following the example, write a word value of 1 to address 0x1000, and a double word value of 32,768 to address 0x1002. Please note, when using double word, the register addresses must be even numbers, such as 0, 2, 4, or 6. Next, write a word value of 123.45 to address 0x1004. To read registers, use the read Modbus command with the syntax, address, size. Read the data from the three addresses and store them into variables, Modbus 0x1000, Modbus 0x1002, and Modbus 0x1004. Once the code is verified, click RL Start. After the program finishes, check the variable values at the bottom. The values are 1, 32,768, and 123. Note that since the data format is integer, the decimal part of the third value is truncated. You can also use the function tab in the helper page. Select 3 from the drop-down menu for the 3 Modbus registers currently in use. Set the output to decimal and configure the used register addresses. Change the second entry to DW, double word, check the box, and click Read to verify the output. Finally, you can use the write function in the helper page to reset all values to 0. Click Write, then read again to confirm that the register values have been successfully changed to 0. Now, we will introduce how to perform continuous writes of multiple values to specific memory addresses. This method is faster and more efficient when the controller needs to access a series of registers. In this example, we will write values to 3 consecutive addresses starting from 0x1000. With the size set to double word, DW, we will write the values 1, 32,768, and 123.45. For the read operation, we will retrieve data from 2 addresses starting at 0x1002. Since the size is DW, it will read from addresses 0x1002 and 0x1004. Once the code is verified, click RL Start. After the program finishes, go to the output page at the bottom. Confirm the output values are 32,768 and 123, respectively. You can also go to the Function tab in the Helper page and click Read to verify the output. The Modbus read and write functions are now complete. Next, we will demonstrate how to use RS-232/485 for Modbus register data transmission. In this demonstration, we use an RS-232 connection for a handshake signal between 2 robot arms. The hardware wiring is shown in the diagram, using pins 2, 3, and 5. Once the wiring is complete, launch 2 instances of DRA Studio to connect to each robot arm. Go to the System page and select the Connection Settings tab. We will first configure RS-232 for the first arm. For the baud rate, choose a suitable transmission speed. Here, we use 115200. The communication protocol format is data length, parity, stop bit, mode. Please refer to Chapter 10 of the user manual for details. We will use 7N2 ASCII for this example. Set the first arm as the master. The station number does not need to be changed. Click Set and restart the controller to apply the changes. After restarting, click Get to verify the settings. Now, repeat the process for the second arm's connection settings with the same parameters. Set the station number, we'll use 2. And select slave mode. Click Set, Restart, and verify the settings. In the master arms RL program, use the arsmasterread command to retrieve data from the slave. The syntax is slave ID, start address, quantity. In this example, we read 3 registers starting from address 0x1000 at station 2 and store them in value 1, value 2, and value 3. Then, use the arsmasterwrite command to write data to the slave. Here, we write 123, 456, and 789 to addresses 0x1003 through 0x1005. Open the slave software, navigate to the Function tab in the Helper page, and write 1, 2, and 3 into addresses 0x1000 to 0x1002. Switch back to the master, run the program, and you will see the values 1, 2, and 3 in the output. Finally, check the slave software again. Read addresses 0x1003 to 0x1005 to confirm the values have been updated to 123, 456, and 789. The RS-232 Modbus read and write operations are now complete. Next, we will introduce how to use the MBC Modbus master function. We will again use 2 robot arms for the handshake signal demonstration. For the hardware configuration, both robot controllers are connected via a network hub. Launch 2 instances of DRA Studio to connect to each arm. For the first arm, go to the System page, Network Settings tab, and ensure both arms are on the same subnet. Set the IP of the first arm to 192.168.1.2. In the Connection Settings tab, configure it as the master. Now, for the second arm, set the IP to 192.168.1.1 and configure it as the slave in the connection settings. Once configured, open the RL page on the first arm and enter the sample program. Let's look at the instructions. The connect MBC command connects to the slave. The format is IP, port, group. In this example, we connect to 192.168.1.1. If successful, RET1 will receive 0, otherwise, it will be -1. SetSlaver MBC defines the slave information, including the station ID and group. SetTimeout MBC sets the timeout duration. Here, we use 100 milliseconds. If the connection exceeds this time, it will fail. The write MBC command writes Modbus values to the slave using a table format, such as A, B, C. In our example, we write 11, 22, 33 as words to addresses 0x1000 through 0x1002. A successful write returns the count of values, 3, to RET4. Read MBC retrieves data from the slave. Here, we read 3 word values starting from 0x1010. The data is stored in Data1, a table type, and we output these to D11 through D13. Finally, close MBC is used to terminate the connection for the specified group. On the slave side, use the Function tab in the Helper page to set up 6 registers from 0x1000 and 0x1010. Input values 1, 2, and 3 into addresses 0x1010 to 0x1012 and click Write. Now, run the project on the master arm. The output will show the values 1, 2, and 3 read from the slave. Back on the slave software, click Read to confirm that addresses 0x1000 to 0x1002 now contain the values 11, 22, and 33 written by the master. This concludes our demonstration of the MBC Modbus master function. Thank you for watching this tutorial video.